Okay, guys, we're asked, and number one, is the sample median, which is here, an unbiased estimator of the population median? We're going to say no, because if you look where this is centered, um, the mean of these is 73.5, and the actual median is 75. So when we look at this one, apparently the median is 75. This would have to be centered on 75 in order for us to say that it's an unbiased estimator. The fact that it's at 73.5 is slightly to the left, and so it's not dead on. And it should be. It should be centered over the actual truth if it's going to be unbiased. I would like you to notice this, though. The original recordings, they go from 40 to 100. And just by taking a sample of size 10 and then getting a whole bunch of those, the spread goes from 50 to 85. It's a bit smaller, isn't it? From 50 to 85. Look, let me do that on this histogram. That whole histogram, that green one, fits in this little range right here. Suppose we had taken samples of 20 instead of 10, and 20 instead of 10. Would the variability of the sampling distribution be larger, smaller, or about the same? If we took size 20 instead of size 10, this would go like this, for sure. And so it would definitely, the variability question, how spread out is, that would definitely be smaller. Describe the shape of the sampling distribution. It is slightly skewed to the left. So I'll write these down real quick for you. It is not unbiased, which is a suggestion that it is biased, right? Let's see, the mean of the mu of those medians is equal to, I'm looking at the book here, 73.5, which is not equal to the 75 that it should be. Number two was, suppose we had taken sample of size 20, the variability would definitely, I mean, that's a big takeaway from this section. It would be smaller. A larger sample size will always make the variability of the sampling distribution smaller. That's a big deal for us. Number three, describe the shape. We're just going to say slightly skewed left and move on. Keep this in mind as we use this concept going through the next several chapters. We're exploring what would happen if we could take every sample of size n from the population. In practice, we only take one sample, and I'm going to keep repeating this because it's such an important thing to us. The reason why we study the sampling distributions now is so we can have an idea as to where our one sample might fit in the bigger picture. You know, if I take the average drive time that you guys come to school, when you drive to school, and I only pick 5 kids, I think it's pretty clear to you that my average might be way off. Because if I only take 5 kids, the sampling distribution would be pretty wide, so I'd have X bars all over the place. I mean, it's possible I ask 5 kids and I nail it, like I get the actual average. But it's not very likely. If you take a bigger sample size, like 35 kids, you're more likely to be close. If I'm only taking one sample, and I need to make big decisions based on that sample, like somebody's paying me some serious cash, like thousands of dollars to do this study for them so they could make $1 million decision, I'd like to ensure that it came from conditions. Like I did my studying in statistics, and I went and I did this in certain conditions that are likely to give good results. And I'd like to have solid background on being able to tell them how accurate, and then I'm going to put a slash and put precise. Sorry, write small. Those two words have a little bit of a different meaning for us. I think I'll get back to that later. I'd like to be able to tell how accurate my one sample may or may not be at estimating the actual truth that I'm going to have them spend their money on, my population parameter. Sometimes statistics, they work out to help people make very, very big decisions. Like think about vaccines for a pandemic, for God's sake. If people want to know, like, what percent chance we have of this thing helping, that's a really big decision. When we do our one sample to see if it works, I'd like it to be under conditions that give us pretty accurate results. See what I mean? Okay, let's go to page 3. And our definition here, the variability. I mean, you guys already know what this word means, right? The variability of a statistic is described numerically by the spread of the sampling distribution. So wouldn't we be looking for standard deviations here, right? The spread of the sampling distribution is determined in major part by the sample size, because the larger the sample, the smaller the variability, right? The spread of the sampling distribution is not determined by the size of the population, and that trips you guys up on the test all the time. It is not determined by the size of the population, it's the size of the sample. Recall that when sampling without replacement, the population should always remain 10 times bigger than the sample. If it's not, the independence condition is violated. And we're going to use that independence condition from the bins scenario in order to make some formulas later on in this chapter, guys. Check out the chart with the targets on page 453. Well, I happen to have a Libro right here. I think it's pretty self-explanatory. It's about bias and variability. Look, there's a lot of bias going on here. That's the target. That's where we landed. It has to do with how we took our sample. You can think of this as if it's a gun that the sight is off, right? And so that creates a bias in where you're aiming. This one has some bias also. These are both biased because they are systematically missing the target. That's what bias is. And you can take a bigger sample size if you want, so the variability shrinks, but you're still going to miss. You can't fix biased data. You can't do it. Now, this isn't biased, but it's got a lot of variability, right? This one is the one with low bias because we're right on target, and low variability. And if I'm thinking about taking a sample and somebody's going to put millions of dollars worth of money into a decision based on the sample I took and the advice I give, I would like my sample to come from this scenario where I did everything I can so there's no bias, and there's low variability because of the large sample size. When I take my one sample, I'm pretty much guaranteed to be close to the truth. That's a big idea for this chapter for you guys. This was about the concepts of bias and variability in one little chart. I hope that was helpful. So by choosing your sample procedures, how do you get your sample? Make sure it's not biased. Make sure you think about that stuff in chapter 4 about how to get a legit sample that actually does represent your population. And then make sure you pick a nice big sample so the variability is low. Your sample procedures, you can create the conditions for different sampling distributions. If you have choices how to pick a sample, pick the one that gives the lowest amount of bias. I mean, that's kind of common sense, isn't it? And the lowest amount of variability, so that when you do take your one sample, when you get your one sample, you have the best chance of getting results. Those results are called statistics. We should name the class that. That do a good job of estimating the population parameter of interest. All right. We're going to go out of the book today. I'm going to go page 456 to 457. I want to keep shaking it up a little. I want you guys to read some. I want you to do some sapling stuff. We're going to go 17 through 20, 24, and 25. And if I don't post the answers, I'm sure somebody like Gabby will email me and yell at me. All right. Have a good day, everybody.